This video will be a derivation of how we get the slope-intercept form of a line. And there are two really important pieces to this. And one of them is that a line is defined with 2 points. It takes 2 points to define a line. So what I mean by that is if you have two points in the Cartesian plane, maybe the point x1 comma y1 and the point x2 comma y2, then there is only one line through those 2 points. It takes exactly 2 points to define a line. If we had 1 point, there would be infinitely many lines we could draw through that 1 point. And if we had 3 points, maybe we had another point here, well, you can see clearly that you cannot draw one line through all 3 of these points. So it takes precisely 2 points to define a line. And after we have these 2 points that define this line, maybe we should call this line L, we can compute a very important number in mathematics, and that is the slope of the line. And the slope of the line sometimes you'll see as rise over run. But if you have these 2 points, then you can calculate the slope. We call the slope m. It's going to be the rise, or the vertical distance, the change in vertical distance, divided by the run, which is the change in horizontal distance. So the length of this segment here, this change in vertical distance, is this y value less that y value. It's the difference of these two y values. So this, which we'll call delta y, and this we'll call delta x, that is change in y and that is change in x. The slope is delta y divided by delta x. It's how much do we go up divided by how much do we go over. So this is y2 minus y1 over x2 minus x1. That's going to be a very important piece of the puzzle. Okay, very good. All right. Now, the other important idea, so the first important idea is that 2 points to define a line. The other important idea is that a line can only have one slope. So, if I have this line here with this point x1, y1, and this other point, we will let this point be a point that we can slide along this line. So we'll let that be variable. We'll just call it xy. No matter where this point is, the slope of that line will be the same. The rise divided by the run is always the same number for a line. So that's the other important piece of information, is that a line can only have one slope. And so for this line, we see that the slope is the change in y minus y1 divided by the change in x, which is x minus x1. Since these 2 points define this line, and the line can only have one slope, so this equation right here really is a definition for this line. So what we can do is take this equation and multiply both sides by the denominator here. Multiply both sides by this number here. So multiply this side by x minus x1 and this side by x minus x1. And what we have is something called the point slope form of a line. So we have x minus x1 times m is y minus y1. It's more commonly written as y minus y1 is equal to m times x minus x1. Now, we're going to use the point slope form of a line to finish our derivation for the slope-intercept form. So we'll have one more picture. This time, we'll have our line, and we'll have this point 0, comma, b. That's the y-intercept. So we're going to have the point on our line that crosses the y-axis. The x value of that point is clearly 0. And the y value of that point is something I don't know. And it also has some other point, xy. And what we do is we use the point slope form of the line to derive the slope intercept form. Now, the point slope form says that y minus y1 is equal to m times x minus x1. Well, what's our value of y1? That's the y value of the point here. That's b. So I have y minus b equals m times x minus the x value of this point, which is 0. Now, x minus 0 is just x, so I have y minus b is equal to m times x. And now all we have to do is add b to both sides, and I have y is equal to m times x plus b. This is the slope-intercept form of the line, and it's called the slope-intercept form because this value m is the slope of the line, and this value b is the y value of the y-intercept. So this gives you the y-intercept. So for example, what if we were given that the y-intercept of a line is the point 0, 5, and the slope of the line is 2/3? Well, then the equation of the line would be y equals m times x plus b. And there are other flavors of problems that you can use slope-intercept form for. For example, what if you're given just 2 points of the line? Well, we know that 2 points define a line, so we can use 2 points to find the slope-intercept form of a line. So what if we have the point, say, -2, 1, and the point 5, 8? Okay, so we need to find two things. We need to find the slope, and we need to find the y-intercept. So the slope, we can find, it's 8 minus 1 over 5 minus -2. This is 7 over 7. This is exactly 1. So we have y is 1 times x plus b. We don't know what this b value is, but we can find it by just plugging one of these points. So let's plug in this point here. When y is 8, then x has to be 5. So this implies that b is 3. We subtract 5 from both sides, and we find that 3 is equal to b. So the equation of our line then is y is equal to x plus 3. So there's the derivation of the slope-intercept form of a line and a couple of examples that use it.